Hello students, today we will start a new chapter. This chapter is named as coordination chemistry or coordination compounds. This is the lecture number 1 of this chapter, and this lecture is presented by me, Vanit Ghatak, your chemistry teacher. So let's begin. So in this chapter we are going to find out what is the coordination chemistry and what is this all about. So before we start to do this, we first know what is the coordination compound. Okay, so coordination compound, what is the definition? So in case of definition, in case to define the coordination compound, we need to say this: the compounds composed of a metal atom or ion. The compounds composed of a metal atom or ion, one or more ligands that are formally donating electrons to the metal center. Okay, so what is coordination compound? Coordination compound are those compounds that composed of a metal atom or ion, composed of one metal atom. Okay, mainly composed of one metal atom, that is only one metal atom generally, or ion, and one or more ligands that are formally donating electrons to the metal center. So here in the case of coordination compound, there should be one metal atom, and that metal atom is attached to one or more ligands. Suppose there is 4 ligands. Okay, this is the ligands for L. Okay, so in the case of coordination compounds, the compound there should be one metal atom, that is M, and it is being bonded with more than one ligands, that is being described as L. Okay, so and all these ligands are formally donating electrons to the metal. This can donate the electron to metal. Okay, so this compound is being called as coordination compound. Okay, where one metal atom will be there and several other ligands will be there, and all the ligands will be donating electrons to the metal. Okay, so what is ligand? I have been said that in the case of coordination compound, there will be a central metal atom. There are metal atom, we know there are three types of metal, mainly alkali metal, alkaline earth metal, as well as transition metals. Okay, but what are the ligands? Okay, so what is ligand? Actually, the metals in the coordination compound, the metals are being attached or bonded with the ligands. So what is basically the ligand? So neutral molecule or ion having a lone pair that can be used in the form of used to form a bond to a metal ion. Okay, so neutral molecule or ion having a lone pair that can be used to form a bond with the metal ion is called as ligand. Okay, so ligand as those compounds that can be a neutral molecule or any ion that can have a lone pair or negative charge. By donating the lone pair or the negative charge, that ligand can make a bond with the metal. So suppose here this is the ligand. Suppose this is L is a ligand and it is a compound with a lone pair. So it can donate. Sorry, this is a ligand and it is having a lone pair. So by donating this lone pair, it can form a bond with a metal. Okay, so a neutral molecule or neutral atom can also be a ligand. Similarly, suppose Cl minus, this is a ligand, and this ligand can also, by donating its negative charge, that is a anionic charge, that is a negative charge, it can also form a bond with the metal. So Cl minus, an anion, a charged species, can also be a ligand. Similarly, in the case of this ligand, suppose in the case of NH3, it is ammonia doesn't have any negative charge, but in the case of ammonia, the central atom is nitrogen, and nitrogen have a lone pair. So by donating the lone pair of nitrogen, it can form a bond. So here the case of ammonia is also acting as a ligand. So it doesn't matter, ligand can be anything. Ligand can be neutral like nitrogen, like ammonia, NH3, and it can also be a charged species like Cl minus. So ligand can be neutral, or it can also be having a negative charge or having a positive charge either. Okay, mainly having a negative charge for an anion, and for a neutral being the ligand may carry a lone pair. By donating the lone pair or the negative charge, it can form a bond with the metal. Thus how a coordination compound is formed. Okay, so there are mainly three types of ligands. Number one is monodentate ligand. Monodentate ligand means they can bond only one bond. They can form only one bond to a metal center. Okay, only one bond to a metal center, metal ion. This is called a monodentate. Monodentate means single bond. They can form only the single bond to a metal. Bidentate ligand means they can form two bonds with a metal ion. They can form two bonds with a metal ion. They are called as bidentate ligands. When they can form which of these ligands they can form more than two bonds with a metal, they are called as polydentate ligand, like EDTA, ethylene diamine tetraacetic acid. Okay, so like EDTA having 6 bonds, having 6 attacking sides. By these 6 attacking sides, it can form 6 bonds with a metal ion. Okay, so it is called as polydentate ligand. So polydentate ligand, they can form more than 2 bonds with a metal ion. So if a ligand can form only one bond to a metal ion, that is called as monodentate ligand. If a metal can form 2 bonds with a metal ion, it is called bidentate ligand. Okay, and if a ligand can form more than 2 bonds with a metal, then it is called as polydentate ligand. Okay, so let's go to the next topic, that is, in the case of coordination chemistry, there are mainly 2 parts. These 2 parts are in the bracket, in this third bracket. In this third bracket is called as coordination sphere. Okay, so whatever present in between the third bracket is called as coordination sphere. So whatever present in between the third bracket is called coordination sphere, and the remaining species that remain the outer side of the third bracket or outer side of the coordination sphere is called the counter metal ion. Okay, if the coordination sphere is positive, then the counter metal ion will be negative. If the coordination sphere is negative, then the counter metal ion will be positive. Okay, so whatever the species that remain in the third bracket, they are called as coordination sphere. Okay, and the rest of all are being said as the counter metal ion. If the coordination sphere is positive, then counter metal ion will be negative. If the coordination sphere is negative, then the counter metal ion will be positive. Okay, and in the case of this third bracket, what we will call as the coordination sphere. In the case of coordination sphere, there are 2 things. Okay, that is, one is metal and another will be ligand. Here in the case of the CONH3 whole base 6, here the CO, that is cobalt, is the central metal ion. Okay, and the other, that is the NH3, is the ligand. Okay, so here you may know, that is, suppose we are showing a film. We are all seeing a film. Okay, in a film, what happens? There will be several actors will be there. All of them are actors. Okay, several actors will be there, but only one will play the role of hero. Okay, another will be played the role of side heroes or side actors. Okay, so here in the case of this coordination sphere, that is, the central atom is 1. This central atom is the metal. Here the metal is only 1. Okay, and this will play the role of hero, and that is being called as, in the chemistry we call as central metal atom. Okay, here the metal atom plays the main character, that is the hero character. Then that is why it is being called as the central metal atom, and other actors, they play the side hero role. Here the ligand, that is the NH3 whole base 6, the 6 NH3 will be acting the roles of a side heroes, and they are called as ligands. Okay, so in the case of chemistry, what we have 2 things, that is the central metal atom and ligand. Okay, central metal atom is the hero, acting as a hero, and the ligands are called as side hero, side actors. Okay, so remember, in between the third bracket, what we call as the coordination sphere, and after the third bracket, if there is K plus is present after the third bracket, then it is called as counter cation. If Cl minus is present after the third bracket, that is after the coordination sphere, then it is called as counter anion. Okay, if the coordination sphere is positive, then the counter anion will be, there will be counter anion, and if the coordination sphere is negative, then there will be a counter cation. Okay, if the coordination sphere is positive, that means if the coordination sphere is positive, the counter ion will be negative. If the coordination sphere is negative, then the counter ion will be positive. Okay, so this was the introductory part of introductory lecture of coordination compounds. Here we have also discussed about the definition of coordination compound and what is ligand and what types of ligand as well, and we have also seen what is coordination sphere, ligands and their characteristics as well. Okay, so that's it for today. We will continue this chapter after the puja vacation as well. Okay, so if you have any doubt regarding this chapter or this topic, please ask me in the comment section below. So thank you very much. Bye.